3-2 is rational numbers. There's a lot of notes today, so we will probably take 2 days. Okay, there's a lot of notes. There's some new parts to this that you've never done before that you're going to need to know. So, rational numbers 3-2. First thing, we got to talk about what a rational number is. And I know for a fact this is a test question. I know for a fact this is a test question. Rational. It's going to say, what is a rational number? A rational number is a number that can be turned into a fraction. A rational number is a number that can be turned into a fraction. So if you think about some of the numbers we talked about, what are some numbers that can be turned into a fraction? Think of yesterday. What do we do? Decimal is one. Sure. What other things can be turned into a fraction? Okay. What else? Can whole numbers? Okay. Just a fraction in general. Okay, so these are the 3 types of numbers we're going to be talking about today. We're going to talk about integers. And integers is a positive and negative whole number. I'm going to have you write a few things under here. Okay, positive and negative whole number. And under decimal, I want you to write repeating and terminating. Integers, what do you mean? Also includes negative numbers. So like I didn't give an example, but I could give like this. That's what I mean to. Oops. This right here? Or this? This is positive and it's supposed to be negative whole numbers. I just wrote NEG whole numbers. Fractions and then decimals. And one thing I want to point about decimals is the repeating and terminating, and I'll talk about that in a second. I want to make sure everybody hears that. One thing I do want to talk about is the decimals. Now, yesterday, we changed decimals to fractions. What did we change to fractions? Terminating decimals or repeating decimals? What did we change? Do you remember? What kind of decimals did we change to fractions? Terminating decimals or repeating decimals? Anybody? No. Terminating, remember? Like if I have, you could write that in a fraction, right? Every decimal we wrote in a fraction stopped. Every single thing. I think we did this as an example. Everything we wrote as a fraction was a terminating decimal. Now, one thing we did not talk about was how to change a repeating decimal into a fraction. And that's going to be part of today. That's going to be the new part of today. Okay? That's going to be later on. So we know how to do this already. This is how we don't know how to change that, and that will be today. Okay? Any questions on this so far? All right, next thing you're going to need to do is you're going to draw me a picture. Okay? Sure, you can draw your picture with the color. No, but I have to tell you how to draw it. Okay? What I need from you is a whole sheet of paper. So like I'm going to use Alex's right here. You have this so far. Keep this because we're going to do more notes. I want you to go to the next page like this and actually turn your notebook so it looks like this. Well, here's his. Here. Here's his. And maybe yours is over here. Yeah, you could do it on the back side, depending. You just need your next empty page. Okay? And then you need to turn your notebook like this because that's how we're going to draw a picture. If you want to, you can get started. This is how you're going to start drawing. Now, You're going to have a line on one side. So on the right side of your page, you're going to have a line. So you're going to leave a little space. I don't know, a few lines. Like your margin is fine, like your header or whatever. Okay? And then you're going to start putting some circles in. Notice how the circles are. I have a smaller one, another one, and a bigger one. Now we're going to write some things inside of there, so make sure that you leave enough space. Make sure you leave enough space. So you're going to have a small circle, I don't know, a medium-sized circle, and then a bigger circle. And we're going to write inside of them. This is where you could use your colors if you want. Each circle will be something different. So, perfect. Okay. Second thing you're going to do after you have your circles drawn, you're going to go up to the top. Like this is my page. We're pretending this is my page in my notebook. You're going to go to the top corner up here, and you're going to write rational numbers. Okay? Because everything on this side of the paper, the circle side, is going to be rational numbers. Okay? All right, I'm going to start with my little circle. Is that right? I'm going to start with my little circle. Now we're going to go through the numbers. Remember we talked about integers, we talked about decimals, we talked about fractions, and whole numbers, and all of them are classified a certain way, okay? So in my small circle, what you're going to write is natural numbers, and we're going to write some more other things in there too, so make sure you leave a little space. We're going to get some examples so you know what a natural number is. A natural number is anything from 1 to a bajillion. All positive numbers, all whole numbers. So for example, 1 could go in there, 7 could go in there, 500 could go in there, 1,000 could go in there. Those are just some examples of natural numbers. So what's another example of a natural number? 40, sure. Anything from 1 up, and everything in this circle is positive. Okay, so far so good. And this one? This is it in this circle. Yep. That's it. All right, then my next circle is called whole numbers. So whole numbers include what's in the natural circle plus one other number. What do you think that other number is that's going to go in there? Huh? No, 1's included in here. No, not decimal. 0 is actually included in here now. So now the whole numbers are 0 and everything else up. So 0, 1, 7, 400, 999. The only thing different between the whole and the natural is the number 0. So what's a whole number? Is most likely a natural number except for number 0. Okay, so everything is a whole number. 0 is also a whole number. Okay, let me turn it around. Everything is a natural number, but 0. Now we go to the whole numbers. That's when you add 0 in. Does that make sense? Okay. 0 is a whole number. Correct. Correct. Okay, then we're going to go to our next one. What numbers haven't we talked about yet? Negative numbers. Okay, so our third circle is called integers. So what are some integers? Negative 5, 7, 1, negative 20. But is also an integer. A positive number is also an integer too. So here's what happens. Integers, okay, so time out. Natural numbers are whole numbers, and whole numbers are integers, but we also add in the negative numbers and the integers. I'll explain in a second. Just hold on. Hold on. So integers include all negatives now. Negative 10, negative 40, negative 500, okay? And also some positive ones. But other ones haven't we talked about yet. Decimals, what else? Fractions, repeating decimals, things like that. So now, outside of the circle, we're going to write some of those things, okay? Because these are also rational numbers, but they're not considered any one of these things. So like 3.1 is a rational number. 5/9 could be a rational number. Maybe not. Yeah, that'll work. Let's see. 7.2 repeating would be a rational number. Another fraction, 3 1/2. Negative 4.7 would be a rational number. Notice how everything in the circle is a whole number pretty much, though. Nothing negatives or nothing fractions or decimals. Pretty much, yeah. That's why we put rational numbers at the beginning. All these things in this side are rational numbers. Okay? Now let me... Yep, repeating numbers are also rational because they can be turned into a fraction. You just don't know how to do that yet. That's what I'm going to show you today. I'll talk about that in a second. Last thing I want you to do on this side is I want you to start here, and I want you to make an arrow out. And I might be like, why am I doing that? But it's helpful. Because what's going to happen is they're going to say, what kind of number is 3? They're going to say, what set in this picture does 3 belong to? We'll start small. What's the first set 3 belongs to? Natural. Okay? Then, if 3 is a natural number, guess what else it is? Following that will help you decide what else it is. Does that make sense? So like if I say, what type of number is negative 4? Well, where does negative 4 start in this picture? It starts here, and then what else is it? Yep, you follow the arrow out. So wherever it starts on that arrow, keep following it out, and that will tell you what other sets it belongs to. Does that make sense? Okay. So if I say, what does 340 belong to? Natural, whole, because it starts here, right? Natural, whole, integer, rational numbers. Just follow the arrow out. What if I say, what kind of number is 2.7? Just a rational number. Because that's where the only place it can be is out here. Does that make sense to everybody how the arrow works? If I say, what about 0? Tell me all the sets 0 belongs to. Integer, rational. Good job. You're catching on. On your homework tomorrow, it's going to give you a number, and it's going to ask you what sets it belongs to, just like what we did. Now, some of you are maybe wondering, well, what about this guy? What's over here? Well, what's the opposite of rational? Irrational. This is our irrational part. You might not have a lot of space to write, and that's okay. There are numbers that are irrational, which means they cannot be made into a fraction. So all these on this side can be made into a fraction. These can't be a fraction. Okay? Now, what are some examples of an irrational number? I'm going to be like, I don't know. Oh my gosh, what's the deal? I know, yesterday was crazy. That sounds like a fire truck. All right, yes.
On Friday, I did see a fire.
Oh, you did? So that's probably what everything was about that. Yeah. Yes. Most likely that's what they are. Not all. Watch this. What if I have something like this? 2.3694197 goes on and on and on. That's an example of something I cannot make into a fraction because I don't know really where it's going to end or what number is going to come next. Another example of irrational number would be pi. Why would pi be irrational? Goes on forever. Yeah, it goes on forever. So like in your homework, it might say, I'm just going to use this because I don't have a remote there. Let's say it has a number like this. What kind of number is this? Rational or irrational? Irrational. Yeah. The ones that really have no rhyme or reason to them are ones that can't be turned into fractions.
So, like 3.1 that ends, that could be irrational?
No, because it's terminating. Terminating decimals you can make into a fraction.
Yeah.
By, let's say you said 3.14. It'd be 3.14. So it'd be 3/14 over 100. That's a fraction. You just wrote in a fraction.
Oh, it can be a fraction.
Right. Those on the other side cannot be made into a fraction. These can. So like these would be terminating and repeating decimals. These are decimals that have no rhyme or reason that literally just go on forever. Okay? Everybody see the difference between the two? Yes? No? Maybe so? Kara, what are you thinking? You're looking at me kind of funny. Okay? Okay, so let's just recap. Rational numbers can be what? Made into a fraction. That includes terminating decimals. And the list you made here. This list. These are all rational numbers. Repeating decimals, terminating decimals, positive, negative, whole numbers, fractions. Those are all rational numbers. This side is everything that can't be a fraction, which is things that go on forever. Okay? That makes sense to everybody? Today, you really don't have to worry about irrational so much. We're pretty much talking about this side. All right? Questions? All right, so a few other things I have to go over. We did that yesterday. I want to go over how to quickly write improper fractions, because this is another thing you might need. What's an improper fraction again? Yeah, it's a number that's bigger on the numerator and smaller on the denominator. So how would I make this into an improper fraction? Alex?
You make the denominator times the whole number.
Okay, you bet. So this would be 8, 9 over 2. Perfect. Okay. What about a whole number? How do I make a whole number even a fraction? Kale? Yeah, over 1. Exactly. Exactly. Don't forget that. I have so many people that say, how do you make a whole number a fraction? Just put a 1 on under it. Change this to an improper fraction. Just quick. What does he look like as an improper fraction? Haley? Negative 13 over 4. 4 times 3 is 12, plus 1, 13. Good. Good job. Any questions on that? Kira? A mixed number? I don't know if it asks you to do that or not. For the most part, it asks you to make improper fractions. It doesn't ask you to go the other way. Do you remember how to go the other way if you need to? Just divide. Yep. Bella? Nothing? Okay. We're going to go on. No, I don't want to do that. I want to do this. Okay, this is the new part today. So remember, you know how to write a terminating decimal as a fraction. Okay, in your notebook, this is what you need to write. Writing repeating decimals as fraction. Now you can get off your page that had your picture and you can go back to your notes. Okay? Now, I'm going to be honest, this is something I did not learn until college. So when it showed up in my 8th grade math book, I was like, interesting. So just know that you might be confused at the beginning. And you probably will be. But we're going to practice. This is why I'm going to expect this to take 2 days for us, okay? So we can get this down. And I will give you step-by-step instructions of how to do it. It doesn't matter. Before I get started, let's just talk about terminating and repeating decimals. So yesterday, you knew how to put that into a fraction, right? Okay, now let's talk about a repeating decimal, like 3, 7, 3, 7, 3, 7, 3, 7. Why can't I just take 37 and put it over 100? It is wrong. Why? Because I honestly don't know where this is going to end. Remember, you have to know what number goes under here. It's where the place value is, right? Well, if I have a repeating decimal, I have no idea where that thing's going to end. I have no idea what place value it's going to stop in because it literally goes on forever. So that's why there's a different method of making something like this into a fraction, because I do not know where it's going to stop. Unlike here, I knew exactly what number to put underneath. It ends in the 10th spot. That's the number it goes. Does that make sense to you guys? So there's another way to put these into a fraction. All right, so first thing you're going to do, you're going to find the decimal you want to change into a fraction. This is it, 8 repeating, okay? First thing you're going to do is you're going to assign a variable. Okay? So you can use any letter you want, and it looks like this. So the book uses N, and I'm just going to use N all the time just because that's what the book uses. You can use whatever letter you want. So N equals 0.888888, and so on and so forth. Now something else you need to write to the side of your paper that's super important. Like, so maybe in your margin or whatever, this is what you need to write. 1 digit repeating, you're going to multiply by 10. If you have 2 digits repeating, what do you think you're going to multiply this time? By 100. 3 digits repeating, what do you think you're going to multiply this time? 1,000, yep. Okay, so that's super important. Like, this is the rule for being able to do this. So make sure you put it in your margin or somewhere that you're going to remember it, like circle it, star it, highlight it like 35 times. I don't care, as long as you remember these 3 things. And I'll show you how to use them in a second. So 1 digit, 100, or I mean 1 digit, 10, to 100, 3,000. Let me know when I can erase it. Anybody still need it yet? I'm guessing you don't need this one anymore. Which one you on, Kira? Done? Okay. All right, so I'm going to go back up here. My second step is multiply. So I'm going to look up here and I say, okay, how many numbers are repeating? Just 1. So what am I going to multiply by? 10, right? 1 digit is repeating and multiply by 10. This is how it works. And don't ask me why it works like this. I don't know. We're going to take and multiply by 10 on both sides of the variable. Okay, both sides of the equal sign. Like, so did you do this part on your paper? Okay, so you're going to, since you have 1 digit repeating, you're going to multiply by 10 on this side and 10 on this side. Right here? I'll show you. So like, if this is a 1, because you can put a number 1 with a variable, right? I did that. So what's 10 times 1? 10, and the n's going to come along with it. Okay? Now, when you multiply by 10 with a decimal, what happens to your decimal, really? If you have 10, you multiply, what happens to your decimal? Anybody know? moves one space, right? Like if you have 100 and you multiply, you have 2 spaces, 1,000, 3 spaces. Do you guys remember that trick? So really, if I take 0.888 times 10, this is what it's going to look like. If you would do it on your calculator, this is what you would get. If you take 10 times 0.8888888, that's what it's going to look like. I know some of you are like, this is crazy. Just trust me, you're going to get it. Okay? It just takes a while. Just takes a while. This is probably the new thing you've learned this year. The first new thing you've really learned, technically. You can't. There's no way to do this on a calculator. If you took 0.88888 times 10, you would get this. Okay? It's confusing. I told you. Just relax. Just relax. Third step, you're going to subtract. Okay? Just relax. This is why it's taken us a while. Okay? So what you're going to subtract is you're going to take this guy up here and you're going to move him down here. So now this is how it looks. 1n equals, and you got to line up your decimals. Okay, that's how it's going to look. And I'm going to put a subtraction sign in there. Our goal is to get rid of the repeating part, because that repeating part makes it impossible for us to know where that decimal ends. All right, so when we subtract, what's 10n minus 1n? 9n's, yeah. Okay, now if I subtract over here, do I have some things that are going to cancel out? This, right? This is all going to cancel. I have this 8 left over, though, because there's nothing underneath of him. We're almost done. Trust me. Fourth step and last step is to divide. Okay, so that's this step right here. My goal is to get the n back by itself, and to do that I have to divide 9 and divide 9 to get n all by itself. Remember, I do something to one side, I have to do it to the other side. And what I have left is the fraction. Then I'm done. If you would take on your calculator 8 divided by 9, you would get 0.888 in the decimal. You can do it if you want. Check it. If you take 8 divided by 9, you get 0.8888888 in the decimal. Takes a long time. Just takes a lot of practice. And we're going to keep practicing it. How did I get 9? I took 10n minus 1n equals 9n. That was one of my steps. I had to take this and subtract it then, because my goal is to get rid of my repeating part. Yep, so I can get rid of that n. My goal is to have n by itself. Remember, your goal is to always have your variable by itself when you're solving an equation. Correct. Correct. Most likely it's going to be a 9 or a 99 or a 999. Most likely it's going to be something like that, depending on what you had to multiply by. Okay? Just relax. Okay, so here's my next one. And just relax. Don't complain. Then you guys have a lot of stuff coming to you yet, because 8th grade math, it gets hard. If you're going to complain about this, then I can imagine what you're going to be like in March. So you got to have an open mind. Open mind. If I look at this, we're probably not going to get through before the bell rings, but we'll continue it tomorrow. If I look at this, okay, first thing I'm going to do is I'm going to give it a variable. Okay? That's my first step. Just wait a second. I have you for a little bit longer anyway. What am I going to multiply by? 100, because how many digits are repeating? 2. So let's multiply by 100. Not on this side and this side. Okay, so then this is what it would look like. Oh, I got to remember my n there. Okay? I'm going to stop right there. I'll continue here tomorrow. Sound good? Fine. Yep, what's that? I will continue here